Okay, so A is 3, because that's the x coordinate of the point, right?
That is our x1.
There is our I don't know, because the formula has it as A instead. All right, and so that means that f of A is 1. And then for this one, we're using x is x. And f of x is 3 over x. Okay?
How do you get that then?
How do I get what? Which part?
Like x in for x.
Right. F of x is just a function of stuff. Okay? No, because she's mad at me. Okay, so now I'm going to take the what? The limit as x approaches 3. Okay, so you could be looking at your note card right now with that original definition of the derivative that I gave you with the a's and the x's of f of x, which is 3 over x minus f of a, which is 1, divided by what? X minus a, which in this case would be x minus 3. Okay?
Yeah.
So the first question is, can you take this and turn it into this? Okay, well, we'll continue to work on that then.
Okay.
All right, so what do you want to do now?
Change 1 into x.
Okay, so Raina says, I've got a fraction up there. I need to get a common denominator. So she's going to rewrite this. I'm just going to do that in one step. As 3 minus x over x minus 3.
Makes sense.
Does that make sense? Because she changed the 1 into x over x and then 3 minus x over, okay? And then what do I do when I have a double-decker fraction? I multiply by the reciprocal, so I'm going to think of this one as being x minus 3 over 1. So I'm going to rewrite this as the limit as x approaches 3 of 3 minus x over x times 1 over x minus 3.
I don't like when you have to rewrite all of it.
Yeah, and a lot of times as a teacher I get lazy and I just write the algebra part, but
I just write them.
that's fine. But as a teacher I'm supposed to do it like correctly.
I'd rather do
You'd rather I didn't? You want me to be a bad teacher?
that.
Okay, what cancels? What cancels?
No, you can put -1 and -1.
Right. I can play the -1 game and I can cancel the 3 minus x and the x minus 3. And that leaves me with the limit as x approaches 3 of
-1 over x.
-1 over x. And so what is my answer now?
You need to put a -1
-1
No, plug in 1.
third. Now I just plug in 3
Oh.
and I get, bless you, Gesundheit, -1 third.
So the negative y is multiplied through this is something else, right?
Yeah.
X minus 3.
Yeah. Okay, but just like yesterday, we're not done. It didn't say find the slope at the point 3, 1. It says find an equation of the tangent line, right?
So use the
So we're going to use the point slope form. So I'm going to go y minus 1 equals -1 third times x minus 3. And I know that that makes some of you a little bit
Yeah, I don't understand that.
geeky because you're not real familiar with the point slope form, but this is just y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. So again, this is our x1 and this is our y1, and we did all this work to figure out what the slope is. Okay? Got your slope, which is the derivative, and then just did a little bit of, yeah, the alternates. Okay, so I'm not sure if I'm supposed to do this using the other form also.
Wait, simplify it out.
No.
Yeah, and it
No.
just makes y equals
So you
x
have to
and
change
x.
the
Or
stuff.
like that.
Please.
All right. In the book, they go through this and they use the other definition. But you guys get it, right?
Yeah.
Okay. So let's see where this comes into play. So this is another thing that you could write down on your note card. You're going to need a bigger note card really quickly.
This one we did. Yeah, we already.
Okay, but instantaneous velocity. So this is the definition of the derivative. So Jefferson,
The alternate
Gabe,
definition.
right? What I'm trying to get you to understand here is that instantaneous velocity is a derivative of the position.
So instantaneous velocity is the same as alternate. It's way over my head.
This is really what you should be writing down because what Jefferson said is true. Okay, so my point here is that the instantaneous velocity is the derivative of the position functions. All right? So average velocity, you would just do the whole y2 minus y1, or, it's the change in distance divided by the change in time. But if you want to do the instantaneous velocity, then you need to take the derivative. And the instantaneous velocity means the derivative at a particular point. Yeah. Yes, and I'm just looking at the book thinking, why do we not have the symbol yet? It's on the next page. Yeah, we're going to get there in just a second. Okay? Instantaneous velocity is the derivative of the position function.
No, what was
Okay.
this?
Okay, so for example, suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. What is the velocity of the ball after 5 seconds? I believe that we did this one already, right? And the way we did it, this was maybe even the very first week of school, is we took the equation and we plugged in numbers that were closer and closer and closer and closer to 5. And we figured out what the average velocity was getting closer and closer and closer to. Do you remember that? And we took that as our answer. What we're going to do today, since we're so smart, is we're going to say, well, we know that the position of the ball at any time t is, they use s for position, is 4.9 t squared. Okay? Yeah, and that's from physics. Okay? So now what we're going to do is we're going to use the derivative to figure out
What's S?
S is position. And I don't know why they use S for position, but they do. S is position, V is velocity, A is acceleration. Why is it P or D or distance? I don't know. Okay, so let's do the H one. Let's do the 0 one just for funnies, just to try something different. Okay. And so if you look at the H definition, it says the limit as H approaches 0 of f of, is it x plus h? Or do they go a plus h? A plus h minus f of a divided by h, right? So in this case, what is a? 5. Okay? A is 5 because this is the position of the ball at any time t, and so we want our time. That's what we're looking for. So A is going to be 5. Okay? So it's going to be f of a plus h. So in other words, that's going to be Do I need to rewrite? I'll go slow. Okay, so we're going to figure out what f of 5 plus h is, minus f of 5 divided by h.
I'm so confused.
All I did is I took the definition of the derivative, the second one, and I substituted in a 5 everywhere there was an a.
Why?
Because I'm trying to figure out the velocity of the ball after 5 seconds. So 5 is the value that I'm interested in.
Okay. Why'd you put the other equation up there?
Oh, we're done with you. But no, a is time, and then what we're trying to do, I thought maybe you would remember from when we did this before, is we have a graph of the ball that's falling, and we're trying to find the slope of the tangent line right here at a equals 5, right?
Why is
And
it?
so, hold on a second, only one question at a time. So, what we did before is we took another point, right? And we drew a tangent line between that point, and we wanted those points to get closer and closer and closer together. Okay, right, and so we want the distance between these 2 points to become 0. Okay, and then that will give us the slope of the tangent line at that particular point. Okay? H is not the slope. No. H is the distance between this point that we want to find it at and another point that we're going to choose. Hold on just a second. Hello? Good morning. Right now might not be the best time. Can we give it maybe 20 minutes? Okay. All right. Yeah, bye. Ms. Herzog wants to see you, but we'll do this for a little while. Yeah, okay. So are we still, you're still not feeling the H thing?
I don't know what the H.
Okay, so let me try this again, because this is important. No, it's important. So here's what we did before, Gabe. Here's what we did before. We said x1 is 5, and y1 is 4.9 times 5 squared, whatever that is, okay? And then we said, let's let x2 be something really close to 5, like 5.1. And then we said, therefore, y2 is going to be 4.9 times 5.1 squared. And we did y2 minus y1 over x2 minus x1 and figured out what it was. Okay? No, just yes, right?
Yes.
Okay, so then what we did is we said, let's keep x1 as 5. And now let's make x2 be 5.01. Do you remember this? Okay, and we figured out, yeah, it was a bunch of work, and we figured out what those things were, and then we went y2 minus y1, dot, 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 and then we said, let's let x1 be 5, and let's let x2 be 5.001, and then we figured out it's probably, 4. Do you remember that? Okay, H is the difference between these two things. It is x2 minus x1. And what we want is for that difference to approach 0.
Yeah, because if H was approaching 0, I thought it should be approaching y2 and stuff.
Okay, so you got it? Okay, good. Let's go back to Leanne in Detroit. Caller, you're on the air. What's your question? I blew you off a little while ago.
Yeah, you did.
Well, because you asked me a question and I answered it, and then Gabe asked me a question and I was talking with him, and then you tried to re-engage, but it was too late. You were done. Okay, so what's your question?
No, just kidding. So what's the equation S of T, what's the form of that? Is that the equation that they gave us?
That's the equation that they gave us for a falling object.
But we're not using it right
We are about to, because that's going to be what we're going to plug 5 plus h into and 5 into to figure out what these two things are, so that we can do some algebra.
So shouldn't it be S of 5 plus H?
now. Yeah.
Oh, would that make you feel better?
Yes.
Oh, okay. Where do you want me to change that? Here?
Yes.
Okay. All right.
We're going to do something. We're supposed to.
Sure. Okay, so now you're happy?
Uh-huh.
Okay, good. I'm happy then too. All right. So then we need to take and we need to substitute in 5 plus h into, as Leanne and Raina pointed out, the s function. Okay?
Yes.
What's that?
5.
Okay, that's all right. You'll be all right. We'll make it work. I'm sorry that they use S for position. I don't know why. So will you right now on your papers on your own figure out what 4.9 times the quantity 5.8 squared works out to be? So I'm going to go 4.9 times 5.8 squared, and you are going to tell me in a second what that is. I paused when you guys were doing the.
It told me I'm beautiful.
What's that?
It told me I'm beautiful.
Oh, well, that's really special.
I
Okay.
told them thank you.
Did they use your name, or did they just randomly write in
No.
your
It
beautiful?
says, hey, you are beautiful.
There you go.
And you just recorded that.
Okay. All right. So now let's make things really, really bad. And now let's find the derivative of a function. And the first thing that you should notice that makes you cringe a little bit is that it's not just a simple old x squared function. It's got 3 terms.
It got really
Okay.
hot in here.
And, but did you hear the heat just turned off, so it's going to be okay. And we're not doing it at a particular number. We're doing it at a. So we're coming up with a formula for the derivative of this function that we could then use to find the derivative at any point we wanted to after we figure this out, okay?
Hey, don't touch the board yet.
Don't touch that dial.
Well, technically,
Oh, because of the
The atoms,
yeah.
the electrons from
Right,
each
right,
other.
And what we're going to do, Gabe, is we're going to mostly stick with the H. Okay? We're going to try that first. And then if that doesn't work, we'll try the A.
this is the force.
So that was sorry, it's fine. Just
Your life
equation.
has changed forever.
No. Another equation.
Okay, so here we go. You ready?
Wait.
Wait, can we factor this? Is that a good idea?
I think we're going to probably end up doing that eventually.
I think we should do
Oh.
it first.
-9 and more. Yeah, -9 and positive 1. Yeah. So we're going to probably do some factoring and canceling. Okay, so x1 is what?
No.
A.
A. And y1 is what?
A squared minus 8A minus 9.
Plus 9.
Minus 9.
Okay? And really, as Gabe and I were talking before, we're doing the same thing as we did before. Now x2 is going to be a plus h. Okay?
Is this what we did when all the algebra reviews?
Yeah. Right, exactly. That's why they had to practice that. And then the fun part is now I have to take a plus h and plug it in to this equation here. Okay? So what is a plus h squared? A squared plus
2A.
2ah plus
H squared.
h squared. Okay? Should be able to do that pretty quickly now. We're doing it a lot. Minus 8 times a plus h will be minus 8a minus 8h plus 9. Okay? That wasn't so bad.
My life's over.
Okay, so now we are going to say the limit as h approaches 0 of this thing y2 minus y1.
No, wait, just plug in.
Do you want me to write it all down and
Mhm.
then cancel?
Divide by
Okay,
h.
so y2 a squared plus 2ah plus h squared minus 8a minus 8h plus 9 minus the quantity a squared minus 8a plus 9.
is that?
What is that?
over what?
Answer my question, which one?
Why did
H.
you change it?
So we're using the H one. We're using the H approaches 0. Okay?
Wait, hold on.
And like when you give her this.
I'm looking at it right now, but it's quite a difficult.
So this thing right here is the f of x plus h, or f of a plus h,
Okay.
right? And then this thing right here is just f of a. Okay?
Yeah, I didn't get that.
It's been messing me up. It seems
So
that.
the A squared
Okay.
Why is it minus?
Because it's in your little formula, it's f of a plus h minus f of a. So it's minus this stuff. Okay? All right, so yes, we do have some canceling. This a squared minus that a squared cancels. This minus 8a and minus a negative 8a would be plus 8a, so those cancel. And then plus 9 minus plus 9 cancel. And so that leaves me 2ah plus h squared minus 8h, right? Okay, good. Now I can factor out an h. So 2a plus h minus 8 all over h. What's that? So the h's cancel,
And then
which
plug in
means
0.
But
Plug
there's
in
an A
0.
still, which is bad.
No,
Yeah.
a is my number. Yeah. So then
Wait,
2a
then plug in-
minus 8. Yeah, plug in 0 for h, so I'm left with 2a minus 8.
Why did you put
Oh my
H
gosh,
versus
you did
A?
that.
Why did I what?
No, it's not C 0, H, right?
Oh, sorry. Oh my gosh, that would be confusing. That's 0. Yeah, we're using both definitions. Okay? So another way of saying this is the derivative of this function of f of x
But truly, that's
is
just the slope.
2x minus 8. Okay? So, if you want to know the slope of this graph at any point x, now you just plug that in there into the formula for the derivative, and that'll tell you the answer. So if you want to know the slope at x equals 2, what's the answer?
Negative 4.
Negative 4. If you want to find the slope at x equals 7, what's the answer? Negative, no, positive 6. Or you could go the other way around and you could say, I wonder at what x value the slope of that curve is exactly 1. So you can set that equal to 1 and then solve. Okay? So you can go both ways now, and it's a lot more powerful when you have the equation for the derivative instead of just the derivative at one particular point. And like I said, I don't know when we get the formulas for these, but I knew this answer before we did any of this.
Of course you did.
Okay?
Why?
Because I know the end of the story.
Wait, no, is there really just a secret?
Yeah, there's a really simple formula that
You never
you're going to
answered.
be angry. I did what?
Never answered me what college.
What college I went to? I got my undergraduate degree in mathematics at the University of Puget Sound, and then I got my master's in teaching at Western Washington.
From
So how made you
Western.
just go all the way from Minnesota to University of Puget Sound?
This just says the tangent line to y equals f of x is the line through that point whose slope is equal to the derivative at that point. Okay, so we're just making the connection again between the derivative and the slope of the tangent line. So wouldn't it be great if we did another example? Find an equation of the tangent line to the parabola y equals x squared minus 8x plus 9 at the point 3, negative 6. Well, what do you recognize?
You just
Give
plug
it
it
the
into
bar.
our equation.
Right, we already did this. We already figured out the derivative of x squared minus 8x plus 9. What was it?
Y equals 2a minus 8.
Okay, and I'm going to leave it with x's. It doesn't matter what variable you use, but the derivative of that is 2x minus 8, right?
Yeah.
So how do I find the slope of this tangent line?
Isn't it already the derivative?
It is the derivative, but I need to know the value of the derivative at that point. So how do I find the derivative
Plug
at
in
that
3.
point? I'm going to plug in 3. So 2 times 3 minus 6 is what? Minus 8, sorry. 2 times 3 minus 8 is negative 2. So that means the slope of my tangent line at that point is negative 2.
Yay, now point slope.
And now I can go point slope. Y plus 6 equals negative 2 times x minus 3. And in my universe, I'm done. Raina or Leanne doesn't like that. You want me to solve it out for y equals, which you can do. And if you do that, you get y equals negative 2x. Okay? But either one of those is fine. On the assignment, you can just use point slope form. Yeah. Okay. Okay. So obviously, the moral of the story here is that if you have the equation for the derivative, that's way more powerful, way more useful than just running around here finding the derivatives at particular points. Okay? Okay, so this just relates it to the instantaneous rate of change, which we already talked about in terms of instantaneous velocity. Please make a mental connection in your brain between those two words, instantaneous and derivative. Okay? When you see the word instantaneous, you should think derivative. If it asks you instantaneous anything, the answer is take the derivative. And actually for the next 2 months, 95% of the questions that I will ask you, the answer is take the derivative. Yeah. So if you don't know what to do, take the derivative. Okay? All right. So a manufacturer produces bolts of fabric with a fixed width. The cost of producing X yards of this fabric is some equation that we don't know. What in this case would be the meaning of the derivative? So if I start with the cost of producing something, and then I take the derivative, remember that the derivative is the change in the y divided by the change in the x. So what would be my y's here? Right, it would end up being the cost per yard, right? Okay, so the derivative we're going to talk about has specific meanings attached to it, you know.
Okay.
So in practical terms, what does it mean to say that f prime of 1,000 equals 9? That would mean that at that point, your cost per yard is $9 per yard. When you are producing the 1,000th yard of cloth, your cost per yard at that point would be $9 per yard.
Wait,
Okay?
when you're buying the 1,000?
No, when you're making it. Okay, so you're running a factory now.
Oh,
And the
okay.
reason why that changes, the reason why it's not the same all the time is because you have some fixed costs, right? Rent, wages, all that kind of stuff that gets spread out the more you produce. So which do you think is bigger, f prime of 50 or f prime of 500? F prime of 50, right? Because the more you make, the less it costs to produce each one. And usually that continues for a long ways, but there's some economic things that also screw this up. Okay, so here is an example of our U.S. debt, and that would be the amount that it's changing at each year. Okay, but that's not important. What?
It's actually very important because it could punch
It's
the
affecting
world.
our children.
Well, that's the same talk as every other
Might as well
talk.
just keep working on the whole the rest of my life. Steady income.
Okay, so you guys have a little assignment to work on there. Okay,
Little assignment.
just a little one. It looks like more problems than it actually is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Can't have homework tonight, Brandon.